What is a spacecraft thermal control system, TCS? Imagine floating in space where temperatures can swing from scorching heat to freezing cold in just moments. That's where a spacecraft thermal control system, or TCS, comes into play. It's like the spacecraft's personal climate control, keeping everything within safe and working limits. Without it, sensitive equipment could overheat or freeze, causing mission failures or even damage. The TCS is made up of two main parts, passive and active systems. Passive systems don't need power. They include things like multi-layer insulation, which looks like shiny blankets wrapped around the spacecraft. These insulate and reflected heat, helping to keep the inside stable. Thermal coatings and surface films also control how much heat the spacecraft absorbs from the sun or loses to space. Radiators are another passive element that emit heat as infrared radiation, helping to cool down parts that get too hot. Active systems, on the other hand, use power to operate. They include heaters that warm up cold parts and louvers. These are like adjustable blinds that open or close to control heat rejection. Pumps circulate fluids through pipes to transfer heat away from electronics and batteries. These systems are essential when passive methods aren't enough, especially during extreme temperature changes or specific mission phases. Maintaining the right temperature is vital because every part of the spacecraft has limits. Sensors and atomic clocks need stable temperatures to work accurately. Batteries and electronics generate heat when they operate, so the TCS must remove that heat efficiently. It also adjusts based on the spacecraft's orientation, whether it's facing the sun or in shadow. Designing a TCS involves considering many factors. Engineers look at the external environment, like solar radiation and the cold of deep space. They also analyze how much heat the onboard systems produce. The way heat moves between components and the spacecraft's structure is carefully planned. Sometimes, special materials like phase change substances are used to absorb or releases heat during temperature swings. Sunshields and coatings help control how much solar energy the spacecraft absorbs and how well it radiates heat away. In crewed spacecraft, the TCS also keeps the cabin comfortable for astronauts. It controls the temperature inside the habitat, preventing overheating or excessive cooling, which is vital for health and safety. All in all, the spacecraft thermal control system is a key part of space missions. It ensures that every system stays within its safe temperature range, no matter how harsh the environment gets. Without it, operating in space would be impossible, and missions could quickly run into trouble.